Okay, we finished the strategy analysis advanced techniques. Now we're going to cover advanced techniques for requirements analysis and design. You will have been exposed, again, to all of these at a high level. In order for us to fit these into a reasonable time frame and to get you out of here, hopefully no longer than 30 minutes late, I'm going to move through these a little more quickly than we have in the past, simply because it's going to be a bit of repetition in some areas. Where it's more complicated or gets advanced, I'll pause and go a little slower. I don't want to just skip stuff you've already covered because I want you to have context for the more complicated elements that we'll discuss. We're going to start with business rules analysis. It is one of my least favorite techniques, so just heads up, it's going to be hard for me to sound real excited. Business rules analysis. This is where we take a look at the policies and rules by which we function, right? What are the things that we have to abide by? They could be explicit or they could be tacit. So they could be like guidance related, or they could be very, very specific with specific data elements and specific calculations. It helps us decide what we do, what decisions we make, okay? Usually we have a defined glossary, preferably. For us to do business rules analysis, we have to have a glossary. Now the glossary could be embedded throughout, but preferably you have a separate, well-defined, agreed upon glossary. Otherwise, business rules analysis can get really difficult and can cause contradictions. So the characteristics of business rules. They are preferably documented in appropriate technology. Terminology. And the terminology are things like must only if, shall only if, things like that. So those are the kind of, I mean, you could teach a whole day on how to write business rules. They're independent from enforcement. It doesn't say to enforce this rule, you have to do these things. It just says that alcohol may only be served if the individual is greater than 21 years of age. That's a business rule. May only if. Or you could rephrase that for must. An individual must be 21 years or older to purchase alcohol. Okay, so there's an example of a business rule. It doesn't say that I'm going to check your license or anything like that. It states what the rule is. It's atomic and declarative. So I didn't specify how, and it was just a statement that was made. It should be monitored and adapted, okay? Let's use the claims process as an example. We said that a claim greater than $1,000 must be evaluated and approved by a manager. Okay, so that's in declarative format. I'm not saying how, but I'm very specific. I'm very explicit in what I'm saying that the requirement is or the rule is. Now, if we recognize that that's causing a bottleneck, we might want to adapt that rule. But usually what that means is if we find a problem through monitoring, we change the rule. We don't just break the rule in that specific situation. We have definitional rules. These talk about operational knowledge, and they usually say how information can be derived, inferred, or calculated. So for example, some of your business rules, definitional rules, would be the way you come about, so what is the policy premium given a specific set of rules. So when you talk about business definitional rules, when you have a solution that looks for specific data elements and then comes to a derived conclusion and then calculates a value based on it, it's running off of definitional rules. It is using rules that are in place, and it's calculating a result because of it. Okay, and because of that, that's really black or white. You can't accidentally misapply it. You can't violate it. It is what it is. So Then we have behavioral rules. These are things that guide actions, right? So definitional rules are things that are usually done by, they're usually pretty automated, and behavioral rules are things about behaviors where they can be broken because people can choose to break them. For example, I can choose to sell alcohol to a minor. I'm violating it. I'm breaking a rule. It is a rule, but I can choose to behave in a way that it's broken. Um, but like, so for example, when I talked about the policy premium, I would have to be provided the user capability of going in and overriding the premium. And I mean, I guess I could build my system in a way that that's possible, but you usually won't see that. Okay. The strengths of this is it gives you an enterprise-wide understanding of things. So if you have business rules well defined, it's a lot easier to write requirements. You can much more readily implement changes related to business rules because they're well defined. Okay, most organizations don't have that, but when you have a centralized repository, you can start reusability. Yes. The right way to do that is to not embed the rule, but refer to it in your requirements. If you write it in your requirement, if you have business rules, if you have a business rule engine, um, and you're writing requirements, if you happen to start writing a business rule within a requirement, it needs to be put in the business rule repository. You should not have business rules that are floating out there not with all of the other business rules. And ideally, if you have a solution that does traceability and you're writing your requirement isn't business rules, your requirement would be something about, a requirement would be validate the user is of age. You don't want to build the actual business rule in, because what if your state or what if the government where you are changes appropriate age restrictions? Now, if you've written the actual language of the rule in all of your requirements, you have to go find every requirement and change those requirements. Or you could change your business rule and do an impact analysis and say, here are all of the areas of the system you need to change to match this one rule. Make sense? I've never been anywhere that happens, if that makes you feel better. You bet. All right. Again, it helps us change policy without altering process, and it helps us change policy without altering a ton of requirements everywhere. Power of reusability. Limitations. When I went to go implement business analysis at a Fortune organization here, that was an insurance company, they had just started their process of evaluating ERP. And they started with writing business rules. When I got there, they had started writing the business rules they'd been working on the business rules for over a year already. When I got there, they were still not done. And they could not write requirements until they finished the business rules. So business rule writing, if you're in an environment that has never documented them before and they decide they want to start documenting them, it can be a pain in the butt to figure out. Now, you can probably go to a lot of the policies and procedures and derive a lot of the rules from there, but man, it can be tough. And poorly defined or poorly organized vocabulary, like if you don't have a glossary and you're trying to write business rules, it can get really confusing. So, any questions or comments about business rules? Okay. The next item is going to be concept modeling. Let's talk about some concept modeling. So concept modeling is that big picture stuff. It's where we organize. It's about business vocabulary typically. Okay, so concept modeling is high-level words where we organize it in a way that we understand how everything connects with everything. It helps us understand the concept of the organization. It manages and it organizes and it communicates core knowledge, not technology and stuff like that, but it's about business vocabulary. It usually leverages glossaries a lot. And it's helpful when you've got a complex situation and you're trying to write business rules for it. It really helps you organize your thoughts and make sure that you're thinking about everything. So concept modeling, if you don't have that in your situation and you're working on a really complex change, it might be worth taking a step back and doing a concept model. And it's kind of helpful because it's a good first step in helping an organization understand their information. Right? So if you know you're going to have to get people to read an ERD and they've never done it before, help them understand the concept first and dig down into the details. If you start at the bottom layer of detail and they don't understand the conceptual idea of it, they can get lost really easily. So they're very different than data models. They're natural, they're businessy, they're not really technical, okay? They're not intended to normalize data. They're not intended to help you understand how entities relate to entities. It's about concepts and how they go together, okay? It's usually about nouns. It's usually about customers and claims and things like that, and how do they relate to each other. Not about the data within it and not the technical view of customers or claims or policies or any of that. Okay, so when we talk about concept modeling, you can leverage verb concepts to connect noun concepts. So usually you'll have the blocks are usually nouns, and you can have links between them that that help you understand how these things relate to each other. And if you think about the business analysis core concept model, if you look at that in your BABOK, here's your concept model. Where is it? That's a core concept model. Now, this is just the business language. So you can see how all of these business terms relate to each other. You have to be careful because you don't want it to become a different kind of model, then it's no longer a concept model. You can say needs drive changes. Changes are caused by needs. Needs are met by solutions. Solutions meet the needs. Needs are defined by stakeholders. Stakeholders have needs. Really high level stuff, okay? So that's what a concept model is all about. It's not a scope model, it's a concept model. The strengths are, it helps us relate to the information easily. It's business friendly. It's not confusing. It's a great place to start, especially when people are uncomfortable about the change ahead. It's not about the data design. It's not about structure of data. It's not about structure of systems, but it helps us communicate better about business rules. It helps us communicate better about decisions and stuff like that that have to be made. Because if I were to look at this and I say needs drive solutions, a rule I could have is a solution must meet a need, or it's not appropriate, right? So I can derive rules out of this. I can talk naturally about rules when I look at the concept models. The limitations are not everyone can think that abstractly. How often are you in a room and you have to pull people out of the rabbit holes? You have to get people out of the weeds. That's not what we're talking about now, especially early in a change. Everyone wants to go straight to the data or straight to the features or straight to the how. And you're like, wait, we have to make sure we're being strategic and we're thinking big picture and we're doing these things. And that requires specialized skill. And sometimes it requires a special you to help others be patient enough so they can develop the skill to effectively communicate with you. If you want this to be stricter and you want it to enforce requirements or enforce behavior in the environment, then it's best if you have an actual tool that helps you do so. Any questions about concept modeling? Some of these are going to be a lot easier to talk about than others. Yes and yes. So when you talk about a project, I assume a project may or may not be about a product, right? So every time you have a project, you want to ensure you have a concept model to start with to help frame your conversations about the change. So let's replace the word project with change initiative, because you may result in, once you finish with your concept model and you guys start talking higher level about it, you may uncover that a project itself isn't necessary. And so while you may, as a business analyst in your experience, you may be one of those business analysts it's very, very normal. You don't get to have those initial conversations to decide if a project is right or not. But your work could result in a project cancellation, right? Because you can uncover, you know what, the problem we thought we had is not the problem we have, and the problem we have is really just training. It's possible. It's happened. Right? So, but it's a lot easier to talk about that conceptually and get people to get out of those weeds and stop thinking about the detailed how and stuff like that if you get them to talk more conceptually. Getting people to speak conceptually is hard. Any point in time. Yeah, but if you're one of those lucky business analysts that gets to be in the ground floor of the change opportunities, it's yeah, you're not. Most of us aren't. But if you are, you would be the one that says, "Okay, we want to look at this opportunity. Let's look at how it fits in the organization. What's our concept here? What are we talking about? What's the business we're talking about here?" Stuff like that. You bet. Okay. Yep, right there. Yep. Okay. So we've talked about we've yes. Right. Yeah, that's not an easy question to answer because it has a lot of dependency in it. So it depends on the people in the room, my relationship with those people in the room, the level of criticality of the change we're engaging in. So, but what I will say is I'm transparent always. It usually works well. Sometimes I have someone that's uncomfortable with, I'm nice, I'm really nice about it. I'm careful about my transparency, but I'm honest. And I tell them, so you need to be, I would recommend you're honest about, we're not there yet, but ask them, and this is where my technique for that is when we come in and and I'm engaging people in understanding what's the problem, where are we going, how could we possibly get there? And I've got people in the room that this is one of the reasons I don't, early on in definition of need, even if it's down at the detail, I try to work ahead of all my technical people. So even if I'm working in an agile environment, I will work with the business well before those requirements hit the sprint, and I'll make sure I understand the big picture and that we're thinking about the right things. And then when we get into the sprint, I don't have to control the room as much because of that. But if my technical people are in the room too early, they always want to go down the rabbit hole. They always want to start designing the solution too soon. So I make sure they have pads of sticky notes and pens in their hands. And I say, that's really important. I don't want to lose that thought. Could you please write that down? We're going to put it on our parking lot so that when we get to the point where we're ready to talk about solutioning, we can get there. But first we need to make sure that we really understand what the business needs, right? And if I have people that are typically problem children, I take care of that before the meeting even happens. And I mean, I've been known to be firm at times. I had a resource that I was telling him I was going to meet with the business because we were having an update. And he was like, I need to be there. Okay, so why do you feel like you need to be there? This is a conversation where I don't even know what the problem is yet. Well, I need to be there. So we had a really good conversation about it, meaning I had a good conversation about it. He was extremely defensive. And I let him know. I said, I can't allow you to influence the business need with your conversations about technology. Technology is supposed to enable the business need. The business need needs to be defined without technology conversation. I need to understand what are the functional needs of these people. Then we can talk about how to do it. But until we've had that conversation, we can't talk about how. We don't even know what. How can we discuss how? I get, and you know, and when we're having those conversations, um, I'm probably a little bit more harsh when I'm saying this to you, but in the room I say things like, "That's a really I love where your head's going. Can you please take notes of that? We need to. I really appreciate your excitement and your passion and your wanting to solve the problems. I need the business to have an opportunity to explain what their problem really is, so that we don't accidentally solve the wrong thing." And the more I know them, that's when I don't know them very well. When I start to, I have been known to, hey, get out of that rabbit hole. Come on, Bugs Bunny. Sorry. I'll do that to them when I know them well, right? If I know them well and we've got that rapport and they'll be like, oh man, I'm sorry, I'm doing it again, right? But that's because I've built that relationship with them and I'm able to not have to, because when you have to tippy toe around it, it can take forever to get them out of the rabbit hole. And I'm like, I need you out now. We have stuff to do and we have a limited time to do it. So, but it really depends. It depends on the people, depends on their personalities, depends on how quick you got to get it done and how much patience you can have with those people. I don't know if that helps. Hmm. I mean, some of these questions you guys ask, huh? Mm-hmm. Yep. What are the rules? Yep. 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 Yeah, and the other thing that you do, and you know, the whole parking lot thing helps them feel like they're going to be heard and their voice matters, because oftentimes if you have technical people in the room too soon, but it's not your choice. Like let's say you don't have a choice, making them feel important and heard is the first step towards winning them over and getting them to do what you need them to do, right? Um, I've I mean, I've been known to say, "Hey, here are the rules of engagement because this is war." Sorry, you know, it's going to feel, we're going to be worn out. There's going to be probably at least sweat and tears and maybe a little bit of blood. And so now everyone is like, yeah, and they have fun, right? So when you know you have that contention, this is where it puts a big challenge on some business analysts. Some business analysts that aren't naturally really gregarious and can't make fun. Humor, making it funny, making it fun can win over people that don't want to like you. When people are laughing, it's harder for them. And I mean, there are going to be some people you can't get to do that. And that's a whole nother conversation. That's more of a coaching conversation. And I can talk about that kind of stuff all day long. So let's talk about data dictionaries. Okay, data dictionaries. This is probably familiar to most of you. This is where we say, what are my primitive data elements? What do they mean when they're together? What are the allowable values? What is this data? Why is it important? How is it structured? Where does, you know, what does it mean? That's a data dictionary. And this is where our data starts. It actually starts in the glossary, then goes to a concept, and then starts moving into data dictionary. Okay, so that's kind of the order. And it can be known as metadata repositories. But let's start with primitive. These are the really basic things. Your primitive data elements are like your primitive data elements. You'll have a name of the data element. What is the name of this data element? Primitive data element name would be first name. What else might it be called? Name, F name, things like that. When you think about this and you're trying to define what a primitive data element is, what are the possible values? Well, when you're talking about things like claim status, what are the possible values? Claim status, the name of the claim status is claim status. What are the aliases? It could just be status. What are the values? It could be submitted, reviewed, approved, denied, things like that, right? What is a claim? What is the meaning of this data element? And what is its descriptor? So let's talk about first name. First name could be called all of these things. The value, it's a text field. It is the way we refer to an individual, and you could have a description. I'm not sure what else the description would be. But then you say, okay, I've got 3 data elements. I've got first name, I've got middle name, I've got last name. When I put those 3 together, I have full name. Okay, so I need to know which data element in which order, and are any repeated? Are any optional? Middle name is optional, right? So when I'm talking about data dictionaries, these are the things I have. And if I were to, I showed you guys my tool, right? And I'm not going to go to that right now, but I showed you my tool and you saw the data dictionary. But a data dictionary is often either in a tabular format. Maybe you have it in Excel. Maybe you're lucky enough to have a tool like I do, right? But a data dictionary talks about what's the name, what's the type, what's the format, is it required, is it unique, is it this, is it that, all of those things, right? My tool even says when it's displayed on a screen, what is its label? Mine does that as well. My solution also asks, where does this data come from? Where's its source? So those are all those are all things that you use to describe a data element in a dictionary, in a data dictionary. It helps us all. Yeah, yeah, my tool has that stuff. Um, so when we're talking about that and we use a data dictionary, it helps us all be on the same page. What is a customer? Well, a customer is first name, middle name, last name, address, blah, 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 blah. What makes up a customer? When we do a data dictionary, we all know. And when we've done a concept model to drive into a data dictionary, we not only know what are the details of that data element, that entity, but also how does it fit in our big picture of our concept model, right? And if we capture it in a single place, in a centralized place that we reuse for referencing, for building solutions, we reuse it, and now we know we can do impact understanding better. So we have a consistent usage of it. We don't accidentally call it something else because we're documenting it in multiple places. We have a centralized place. That way we always refer to it to the same way, and if it changes, we know everything that it impacts. So that's a really great strength of leveraging data dictionaries. The limitations are if we don't upkeep it, it becomes obsolete, and then we can't really use it very well. Often we don't necessarily keep it up, but until we do a change, until we have a new project for that specific element or that specific entity, and then we revisit that entity in the data dictionary, and we change it to be used in the new project. If we want to manage it well, we have to use metadata, or it's kind of useless. So we need to maintain it, and we need to take the time to consider the attributes of that, which is your metadata. Okay. Any questions about data dictionary? Yes. Uh-huh. Right. Yeah. Yeah, they are, and the elements you need to keep track of are often defined by the business and what they care about, because that drives what kind of features and functionality and capabilities you need to provide them to manage that data, which drives the kind of metadata you need to keep track of. And what are the specific, when you talk about an entity, what are the data elements of the entity? So yes, and most people use Excel. Not a lot of people have a tool. Some of us are just lucky. So Nanny, I'm kidding. I've been with you guys long enough that I'm starting to let a little bit more me peek out. Okay, so we've done the data dictionary. I'm actually going to skip data mining. Yes. No, there's no overlap. So glossary is big picture terms that are used in concept modeling to show us how those glossary elements are related to each other. And then so you can have, let's talk about claims. Your glossary is going to have what is a customer, what is a claim, what is a policy, what is these things. And then all of those glossary elements are going to go into a concept model that show how they're related to each other. And then I'm going to take that customer concept element, I'm going to create an entity out of customer, and then I'm going to say, what are the data elements of that? And that's my data dictionary. Okay, so now we're going to model it. I'm skipping data mining. I'll come back to it. Now we're going to model the data. Okay, so now we need to make an understanding of how do these data elements, how do they relate to each other? What are their attributes and how do they relate to each other? How do they affect one another? There are several types of data modeling. Okay, we have conceptual. This is the high level. This is this is going to look very similar to the concept model, but it's different. Now it's not about the business terms. We're turning it into the data elements. Now, it could look almost exactly the same, but the way we represent the information is going to be different. Okay. Okay, so we can have conceptual. This is where we're just talking high level. We've taken your glossary and we've taken your concept model. We've converted that into the data elements in a data dictionary. Now we're going to say, okay, those entities, I'm going to put those in a conceptual entity model. And I'm going to use actual entity diagram elements, okay? And then I'm going to turn that, this is where remember we talked about layers of abstraction? This is like taking data and then layering the abstraction. The glossary and the concept model are the really highest level, executive level. That's that viewpoint. Okay, that's the executive level abstraction. And then you get down into the data dictionaries, and now you've actually stepped down a couple of layers because you're getting into detail, and now you're going to go back up to a middle layer of detail. So this is your second layer of abstraction where you take that detailed data dictionary and you turn it into a middle layer of detail about how the data relates to each other to support those business concepts. And then I'm going to convert that into the next layer of logic where I'm going to start saying, okay, now I'm going to say one to many, many to one, but from a logical perspective. And this is where you might get into trouble with your technical resources. They're going to think you're trying to design their data tables, and you're not. I mean, I've had that problem where I had a DBA from Microsoft that I worked with, and he was not very nice when he told me I was outside of my pay grade. So I very politely explained to him, I'm trying to help him with I'm trying to make the communication easier between us. I don't know how else to communicate this in a way that it makes sense to you. I'm just trying to help you understand how the business sees their data. You might turn it into something else completely. Now, I get your frustration. I get where you're coming from. Just please give me this one opportunity to show you what I mean. You know, I think he was assuming I didn't know what I was doing. And then I put my logical data model together. I give it to him and he's like, oh my God, do you know how much easier that's going to be for me to create a physical data model now? I need you on every one of my projects. And I'm sorry, I love you, but I can't do that. I'm one person. But I can teach other people how to do it, right? So those are the three layers. You'll have your conceptual data model that gets a lot more detail for a logical data model, which is from the business perspective, and then you'll go down into the physical data model. Now, my logical data model still looks like this, but it's from a logical perspective from the business. It might look different when the physical structure is developed or designed. Okay, because I'm going to do it from a perspective of how the business sees their data connecting. The developer or the DBA is going to think about security and performance and concurrency, and he's going to normalize that like nothing, unless we're dealing with flat tables like HANA or something like that. But more often than not, you see normalized data still. Okay, so those are the different layers. You can also have object diagrams where you say, okay, so particular instances of entities from a data model, you can show how that works in object diagrams for object-oriented development stuff. So the very first level of it is an entity or a class. Okay, so this is where we have something physical, like student. This is my entity. Okay. It's abstract, maybe it's an event, but usually it's an element, like it's a customer, and then you'll have customer, and then you'll have policy, and then you'll have other things. You'll have multiple entities together. They're still the same thing, but if you're working on class, so if you're doing an ERD, it's entity. That same element in a class diagram is called a class. Those are interchangeable. Now, what you do need to be aware of is that if you get a question that asks you specifically about class diagramming, you realize that that higher level of data element is a class. If they're asking you a question and they use language associated with entity relationship diagram, you need to understand that that highest layer of abstraction of data is an entity. So that's an important distinction for you to make, okay? And then you will have a class. These entities or classes will have attributes with relationships to others, but we'll get there. Right now, just be aware that we'll have several boxes on the page that are about an entity. And then those things will have attributes. They will be particular pieces of information associated with an entity. For example, how big is it? When you talk about the piece of information associated with an entity, how much information can be captured? How big is it? What type of data is it? Those are the attributes. Now, a lot of entity diagrams, a lot of data diagrams won't necessarily show that. You would actually have to provide a data dictionary in conjunction with your ERD. I very seldom see this stuff in ERDs, but it could be there. And the allowable values. The allowable values are part of this stuff and the type of information it represents, but usually you're going to find that level of detail. Usually you're going to find that in the data dictionary. Very seldom do I see it in the ERD. And then you're going to see how it connects. How are these things related to other things? So when you talk about the entity, it's going to be one to many. So one and then n is 0 to many. So this relationship or association tells you the story about how these entities are related with one another. So it usually has a cardinality. Is it so you'll know whether it's required. So it would be at least one, only one. It could be 0 to many, 0 to 1. There are all kinds of things that this could represent, and what number is on what side tells you how they're related. Okay, so when you're yes, yep. So in claims, a customer is an entity or a class. A policy is an entity or a class. The relation attributes are like a customer. The attributes are that you're going to have data elements associated with it. And then those data elements associated with it will have their own elements, their own attributes associated with them. So you're going to have multiple layers there. And then you have the relationship between them, the lines that help you understand what's related to what. Okay. So in an entity, say that again. Okay. And in a class, they look very, very similar, but an entity relationship diagram and a class they're called different things. They look very, very similar. Each one of them is going to have metadata. So metadata helps us understand what these things represent. Why are they created? When? How should they be used? How often are they used? So customer is going to have a set of metadata, but then customer is going to have first name, last name, stuff like that, and each one of those are going to have their own metadata. So it's important to understand that distinction. So if you were to look at an entity relationship diagram, you're going to see, like, this is the one that I use the most. It's I believe this is Gain Sarsen, I'm pretty sure. And so this tells me this is one. It has to have one. This means it's optional, right? But many. Okay. Does that make sense? I think that is what that means. Hold on. I might be mistaking that that line there. Shoot. My system helps me know that. Oh gosh, here's a good one, but you can't see it. So this is what they typically look like. Okay. So that's what an ERD typically looks like. You'll have so here's the subject with, and here's the class. A class has a teacher, a group, and a subject. So here's your subjects, goes in here. Students have grades. Subjects go into this. So this is a combination of students and subjects, and the teacher will update it. But this is so This is Lucid Chart. Oh gosh, they're not great at that. Do you guys, is it making sense to you at all, or did that confuse you? So here's a clothing product. It falls within, here are the categories. So a clothing product falls within a specific category, typically. Here's your detail on your categories. And then you have sizes of the products and the colors that might be in there. So it pulls all of that together. I have much better examples than this is giving you. Oh, here you go. One to many mandatory. I had it right. This means at least one. This is one and optional. I had it backwards. I'm sorry. At least one, optional, multiple. This is many, one or more. So this is one or more, meaning at least one, could be many. This is could be many, could be one to one, things like that, right? This means zero to many, optional. 0 or 1, optional. So this line here means optional. Does that make sense? I see RADD. Class diagramming looks a tiny bit different. Not too terribly different. They use, with class diagramming, they use these instead to show the kind of relationship. And in your book, this is probably what you really need to look at. Okay. Crow's foot notation is what I use. This is what I use. So this is where you can see any number 0 to many, 0 to many, 0 to 1, only 1, any number from 1 to many. Okay, so that's cardinality. And the next page should show class. So class uses X's and X to, so it uses the number. So it'll say 1, 1 to star. And then it also does something that this is not showing you. So apparently you don't need to know it, but it has like diamonds or arrows, and that means specific things about how it's related, not just cardinality. So you will want to understand the difference between what class looks like versus this, and you will want to understand this means 0 to many, because you could be given a diagram and asked to interpret it. Okay, what is the requirement you can derive from this thing? Okay. Now, what's good is it can help us really communicate easily what is the data, how does it relate, what does it mean to the business. There's nothing as good as this to do that. And it will provide a consistent approach to analyzing data and the relationships. Now, the limitations are that people that don't understand what they're looking at are going to need your help. And it usually requires multiple people to provide good information about it. Any questions? Keep in mind, we are at this point officially over time, and I will have a hard stop by 12:30. Okay. Okay. Now, let's talk about data mining. This is a pretty short slide deck. This is often not done by a business analyst if you have a data analyst available to you. But this is where you just, this is used with your benchmarking, right? So you know what you're looking for. You have the specific data idea or the specific thing you're trying to understand. So you go get all this data. Once you've done that, it's all about looking at that data from a holistic perspective and trying to find patterns so you can learn from it. Usually it's represented in a statistical approach, and it's often used by people who are leading people to figure out what are we doing well, what are we not doing well, what does this mean. It's used in marketing to understand your potential consumers. So data mining is a way for us to understand, get insight into stuff. Okay, this is how we turn data into information, data mining. The techniques we can use, we have descriptive, diagnostic, predictive, and go back, and predictive. Now descriptive is where we're trying to tell the story of what are our customers. What are our customers? What do they care about? That's just, I'm trying to describe it, okay? I'm not trying to do anything with it yet. I'm just trying to describe it. It could be diagnostic. I could be pulling data for the specific intent to uncover problems. Why is this not working? Why are the customers not buying from us? Not just trying to understand who are the customers so that we can design a new product or something, but what's going wrong? And predictive could be, I consistently go about doing analysis on data to figure out, am I gonna run into a problem? Are my customers, is their interest in us declining? And what does that mean? When are we going to not have enough customers? Maybe it's system performance. I can use data mining on the scalability of a solution I have to determine, is it capable of supporting our processing needs over a given period of time? Can I predict out when it's going to run out of space? Stuff like that. Okay, so descriptive, diagnostic, and predictive. First, you have to understand, what are your goals? What are you trying to understand? Right? Then you're going to get the data, and you're going to figure out, what kind of data am I looking for in order to figure this thing out? What kind of data am I looking for? What kind of sets do I need to build so that I can actually acquire the data? Once I have the data, what kind of modeling techniques am I going to leverage to make sense of the data and to put it into an understandable picture? And then I'm going to deploy those resulting pictures for people to use. So the people that work in like Power BI and stuff like that, someone comes to them and says, I need insight into some data. Awesome. What are you looking for? What is your goal? What are you trying to understand? They have that conversation. Okay, great. So for you to understand that, I need to go build some cubes of information for you in the BI tool, and I'm going to go build those cubes. I'm going to get the data pulled into it, and then I'm going to apply certain models to it, certain analytical models to that data set, put it into some kind of charts that you can make sense of, and I'm going to deploy it to a location that you can access. That's what data mining is all about. Now, you could be in an environment that's done by a data scientist. If you don't have a data scientist, it is an analysis process. And that's why there is that big confusion between business analytics and business analysis right now. What's good about it is it's actual data. Now, you got to use it right, but we can, if we do data mining well, and especially if we leverage cool tools to look at it and massage it, it can give us insights that we'd never before been able to get. If we integrate it into a system design, we can get better data. So if we start trying to, when you start trying to build out analytics, you can uncover that you don't have a good structure of data right now. So when you go design your solutions, you have better understanding of what does the data need to be to give us the insight we're looking for. And the data analytics, you can combine several. So if you look at the techniques of the solution scorecard, you're using analytics about the capabilities of systems to help people make better choices that are less emotional in nature. Analytics help us make unbiased decisions. They help us make decisions based on data, not emotions. Okay. The limitations are that it does require specialized capability or knowledge, and it can take considerable effort. And if you don't, you can have the right need, you can have the right data, but if you apply inappropriate algorithms to understand it, you can get incorrect results, and you can accidentally use it incorrectly, both ethically or just get wrong requirements. And because of the level of complexity, you may not get a lot of transparency about how that information was derived. And sometimes people won't trust information. If you give people results that aren't what they were hoping to see, they may blame it on inaccurate data. Okay. Any questions about data mining? Because people want to blame you. So if you get all the right data, but you apply incorrect algorithms, right? You understand if you mess up on the way you're applying algorithms or the analysis patterns to get your, because you could, if you try to correlate data the wrong way, you might get a completely different story. So it's important that you really understand the measurement you're trying to get, and you understand how the data relates to it, to how to relate a date relates to itself, so that you can say, okay, I need to connect this data with this data in this way to get this result. Because you can connect it all kinds of ways. And it'll come out with uh-huh. Yeah, you can. Yep, that's an example. Okay, any other questions before and I've got to ask you guys a question. Okay, we still have a few. What I don't get through, I can pass off to LN. Do you want to continue going till 12:30 so that you can get the best of your time with LN? Okay. All right, so let's cover decision analysis. This is going to be a little bit of repetition because we did talk about this. Decision analysis is where we take a bunch of information, we evaluate it in a structured perspective, usually in a matrix, so that we can make difficult decisions easier. It takes all of the possibilities, all of the possible consequence of different decisions we could make, and it compares it to others so that we can make good choices. So we need effective decision analysis to prevent, so that we can have values, goals, and objectives relevant to the decision problem. We have to make sure that we have that, or we're going to come out with the wrong decision. So the first step is saying, what is the decision I'm trying to make, right? We need to have goals and objectives that are relevant to the problem we're trying to solve. We need to figure out what kind of decision am I trying to make? Am I trying to choose between solution options? I'm going to go about my decision analysis differently than I am if I'm trying to decide if I process this claim, right? So there are very different decisions there. And anytime we're doing this, we will have areas of uncertainty that affect the decision. We need to be aware of that. We need to be understanding of that. Those are assumptions. When we have uncertainty, we have to make assumptions, right? So it's important that we communicate that. And then the other thing we need to think about is the consequences of each possible decision. We need to communicate that. So all of these things need to be represented in whatever we deliver that is the decision analysis result. So the steps are: describe the problem, figure out who's responsible for managing that problem, because you're going to go ask them a lot of questions. What are the possible results? What are the possible solutions to the problem? What are the criteria we use to make the decision? So for example, if you are in strategy analysis, what you're doing is you're saying, I need better client engagement. It's the combination of salespeople, customer service, and client fulfillment that's responsible. Well, we could implement CRMs. What are the possible alternatives? I've narrowed it down to 3. What decision criteria do we need? How well do they meet the requirements? How expensive are they? How good is the vendor in communicating and delivering? Right? Those are the kind of examples. So you can have a simple decision matrix where each alternative is just measured manually. We talked about that the other day. I would expect, did you guys cover this the other day? I think it was, you might have been with Peter, where you say, here are the requirements, here are the options, and I covered it with you in strategy analysis at a high level. This is a decision matrix that's kind of was mentioned in strategy analysis and requirements analysis and design, where you were weighing solution options to make a recommendation, right? So that's the basic, but you can have weighted. And this is where you say, based on how important this is, it gets a percentage of value of a score, right? So usually you'll say, here are my requirements. Do you meet it out of the box with configuration, with customization, yada, yada. If you meet it out of the box, it's 4 points. If it's a must-have, that means it's the most critical, you get all points. If it's a should-have, you get 75% of the points. And the reason for that is if they meet all of my would-be nices and very few musts, I don't want them to get a higher score than someone that meets most of the musts but almost none of the would-be nices. So weighted decision matrices are extremely valuable because it helps us ensure that we're giving the most attention to the most important elements. Okay, trees. This is usually like your business rules are usually embedded into decision trees that help you decide, what do I do next, right? So for example, when you're trying to decide on, do I cover this claim? Or when you're trying to decide on, do I do this next step? So it helps you say, if I do this, this happens. If I do the other thing, this happens. But this one can lead to this decision, which can lead to this decision. And ultimately, everything has a final outcome. And you figure out what is the outcome I'm looking for that determines the way I go through that decision tree. Now, every decision I'm making, I need to think about the trade-offs. And this is the best example of this is, let's go back to CRM. I have these three options. Cost benefit, all this stuff is there. But I also need to say, what are the trade-offs? If I do this one, am I missing something with this other one? If I have multiple options and they might conflict or they give me a little bit of a different thing, first it helps me, when I talk about pros and cons of each, it helps me easily eliminate obviously inferior options. It helps me rank them. This makes a decision between solutions much easier. Even if it's close, this definitely helps. The strengths. It helps us evaluate values of each alternative. It keeps people honest. And it actually, in my recent experience, resulted in someone having to admit they were emotionally attached to a solution and they took themselves out of the decision process, which was huge, and it helped the team make a better decision much more quickly. And it makes us make decisions based on fact, not feelings. And it forces us, when we go through this process, it forces us to construct suitable metrics so that we can compare not just financial but non-financial outcomes. Now, the limitations of this decision analysis is that you got to know what you're looking at. You got to understand probability, because each result has a probability of outcome. Everything isn't certain. And so it's necessary to understand what that means, right? You got to realize you're guessing at possible outcomes. And it only works if you have the right amount of information. And if you're working with limited information, it's important to be honest about that. And just like all the other numerical metrics we've gone through, people can treat it as more certain than it is. Okay? Any questions about decision analysis? Yes, it's important to comment on those. Yep. Yes, sir, it is. Okay, that leads us straight into decision modeling. So you've got your decision tree, right? You've got your decision elements. You're doing analysis. To make that easy to understand, we model it. It shows it in pictures. It makes it easy to read. It's often in the form of tables. Sometimes it's in the form of trees. Sometimes it's actual decision modeling, right? But it helps us put it into pictures. It's not just conversation. So we've analyzed it. Now we actually represent it with modeling. This is a decision tree. This is the decision we have to make. These are the possible outcomes of that. Based on this, I need to make this decision. And ultimately, we have 7 possible outcomes of this one decision I have to make, right? For example, claims. Is it easy? Is it under 500? Yes. Is everything available to me? Yes, cover it. I'm sorry, is everything available and it's covered? Yes. Is everything available, but there's something questionable covered? Okay, and then, so you see what I'm saying? So it can come out to multiple options. Decision trees. Each level represents a specific data element. Each one of these are conditions that might be the case, and they can lead to other decisions. Ultimately, you have some final outcomes. So when you talk about decision requirements diagrams, this is different. This is where we say, okay, here are the decisions, but it also gives you information on what goes into making the decision. It's not just the decision tree, it's a lot of other stuff that goes into it. What are the decisions? What's the data that goes into it? What's the knowledge base needed to make the decision? Things like that. So when you have a decision, you'll have business knowledge. So for example, my decision is, do I pay this claim? I need to have business knowledge of coverage. And then I might have a knowledge source of policy coverage details. So I need to understand that. And one of the things you're going to want to know about decision modeling is that this is the image for business knowledge. A knowledge source looks like a document from a normal thing, and decision is a square box. Okay? So those are the things you're going to want to know. Now there's this thing called DMN. If you really love talking about decision modeling, there's a new decision modeling notation out there. It's pretty cool. When you put it into a model, it makes it easier to share and understand. Everyone gets on the same page. It's easier to reuse it, and it helps us understand the impact of our decisions. The other thing is that you can combine these into other things, especially when you use a diagram, to help perspective. For example, you can embed decision modeling into business process modeling. So everywhere you see a diamond, you can make your business process models easier to read by incorporating decision modeling in place of the diamond. So you put the diamond there, but right before the diamond is a decision activity, and that blows out into a decision model. If it's really easy, don't use it. This is work, man. And it might limit rules to those required by known decisions. And not everything is what it says it is on paper. So we need to realize that some people are going to have behavioral modification. And sometimes when you have cross-functional rules, some people don't necessarily agree on all of it. So it can be difficult to get those decisions that require multiple groups to work together. Sometimes it can be difficult to get sign-off. Any questions? Okay. So we've talked about data modeling. We've talked about decisioning. The next thing would be non-functional analysis. So let's talk about non-functional, let's talk about non-functional requirements. That's not what I wanted. Non-functional requirements. Non-functional requirements are not always easily documented. These are the things that are under the covers. This talks about how well a functional requirement is going to perform. It's usually called quality. These are the quality elements of a solution. And it's usually presented in text. It's usually not modeled out. The categories. Anytime you see ility, right? So if you look at the non-functional analysis area in the BABOC, I'm trying to remember if it specifies all of these. Yes, it does. Okay. How available is it? Can I get to it when I need to? Is it compatible with other things in the organization? How well does it meet the functional needs of the user? Can they use it easily? How hard is it to maintain it? Is it so convoluted that it's really difficult to reuse components or test it? I have to write code every time I want to fix something. Does it perform well? Can I easily transfer the solution or a component of it from one environment to another? Like if we move to Office 365 instead of just Office, how well can I deal with that? How reliable is it? Will it grow for me? Does it meet our requirements for security? If you're working with healthcare stuff, you better be PII, HIPAA, those better be secured, things like that, right? Usability is kind of nebulous, but you do have to be able to measure that because people need to be able to use it. Does it have to be certified? Like, do you have to be SOC compliant? Or does it have to be things like that? How well does it deal with the culture of your organization? Meaning, can I deal with multiple languages? Is it, how well does it deal with current laws or currencies, things like that? So does it conform to the locale that it has to be installed in? Does it meet your SLAs, right? Critical issues have to be resolved in an hour, in a day, in whatever it is, right? Can it grow to do other things for us? And does it comply with the law? There are a lot of other non-functional categories, but these are the ones that your BABOK focuses on the most. It must be quantified to the extent that it's possible to be verifiable. Not all of these are easily done like that, like usability. It's hard to measure that. Just do your best, right? Based on the stability of the context in which it is, it might be modified based on that. So you might have something that you might have a requirement that says it's highly stable, but the more, or highly portable, but the more you learn, right, the more you realize that's not correct. So you might modify it as you go through. So an example of quality is the system shall provide 90% of responses in less than 2 seconds. That's a responsiveness issue, okay? That's an example of quality. It's not how it responds, it's not the functionality it gives, it's in the back end and a user doesn't touch it, but a user is impacted by it, and this impacts how well those functional requirements are met. It's really good because it helps your technical resources understand how well the solution needs to perform, because they can code things differently based on your non-functionals. Okay, so it's important that they understand that. They might build the database differently. They might change the scalability of it. They might apply different levels of volatile RAM to it, things like that. Okay. The limitations are that it's hard to communicate it. People usually have a really hard time clarifying, what does usability mean? What kind of things does it need to be portable into? How much does it need to scale? Sometimes it's hard to define all of that. And sometimes it's difficult to get agreement because they're some of them feel nebulous. And if you're not careful, like if you were to say 99% of them need to respond in less than a second, that can get expensive to implement. So we need to make sure that we're being reasonable with our non-functionals. And I got to be honest with you, I very seldom have seen non-functionals documented. Okay. Any questions about non-functionals? Someone specifically talked about prototyping. I'll cover that one, and then we'll leave the rest for LN next weekend. Okay. Well, like that example of the system response time, 90% of system requests should process in less than 2 seconds. That's a responsiveness requirement. Accuracy, the solution must maintain accurate data understanding to the second decimal. That's an accuracy statement. Reliability, that the system must have 99% uptime availability. Those are some examples. You bet. Okay, last slide deck we're going to cover, prototyping. Widely used when we're talking about software products, or even just products that are consumable like iPhones and stuff like that. It helps us communicate the user's experience requirements, so UI and how that integrates with other things. It's all about the user experience, and it helps us validate the needs of the users significantly better than almost any other technique. Anytime I'm designing changes to existing software vendor solutions or implementing brand new software, I prototype. I don't ask permission, I just do, because it greatly changes how successful my solution will be for those users. So we've got two kinds. We've got throwaway. That's usually where it's not reused. I design it. It's usually like it can be in Paint or Visio, or my tool does it on a napkin, on a whiteboard, because once we're done with it, it's not used in the actual solution. And then you've got evolutionary. That's where you're building things in, like there's some like PHP and Python and stuff like that, where You don't have to have a ton of coding experience, and you can actually build out those prototypes, and when they're done, they're actually published with change. If you're an SAP functional expert, you as the business analyst, you'll not gather, I can't believe I just did that. You'll elicit the requirements, and your design work, when you're doing your prototyping, you're actually in the SAP interface in the sandbox, you're building that out, you're showing it. And then when they tell you what's right or wrong, or if your requirements aren't met, you tweak it right there. That's something that actually goes to production. That does take more effort though. I usually do more throwaway than anything. So prototyping methods. I might use paper. I might use a storyboard. In a storyboard, I'm like showing the sequence of activities, and it's like almost like what you see people doing when they're building out films and stuff, but it's from the perspective of a user using a system. I might draw it on paper and pencil. I might show, when I do workflow modeling, a workflow, a process model is a prototype. I'm prototyping the new workflow. Or I might do a simulation type prototype. And that's where you are using it to demonstrate the solution or solution components. If you're using wireframes or something like that, that usually falls into the simulation. And I would expect that's where more of you work, unless you're drawing out a prototype on paper. Now, the strengths are, it's great at articulating need. I get significantly higher percentage of accurate requirements using this. The throwaway type, like what I do, it's inexpensive. I can throw them together real quick. When they give me feedback early, I'm actually able to fix it. And then I'm not having to undo code and redo code, or undo system implementation or redo system implement, or, I'm not having to work in a system to fix it. I'm just moving some stuff around on a screen that doesn't have any real impact to anything, and it's really quick. And when I do it, it's usually, so when you talk about vertical prototype, that's where you're building something that digs down into the weeds. Like when I'm designing a screen and I'm talking about where data comes from, and I'm talking about how the system will respond to a user in detail, that helps me really dig into whether something's feasible or not. But that can be expensive and that can be time consuming. So usually I do throwaway. It's kind of like at that middle level. I don't get real deep. It's just about the user experience with the requirements and the process, and I tie all of that together, and I get high levels of accuracy on my requirements. And when we do that, and I do it quick, doesn't take a lot of time, and I do it in my iterative development stuff, even in Agile, and we have a lot less undo, redo, burn down rates go down, stuff like that. Limitations, it can take considerable time, especially if you're not doing throwaway. If you're not doing throwaway, number one is absolutely accurate. And honestly, in Agile, that's what you're doing often. You're doing a lot of prototyping, but it's the real thing. And if you don't have your requirements right and people aren't painting the picture in their head very well, that can get pretty expensive. You're making assumptions about technology capability. And if you're not careful and don't communicate well, because it looks so pretty already, people seem to think you're almost done with building it. So it's very, very important to set expectations that the solution still has to be built. And if you're also not careful, they focus too much on the design elements and not the requirements. So when people start getting excited and start asking for stuff that's cool, I have to get them focused back on, what do you really need? Not what do you want, not what would be neat. And if I've got my technology resources engaged too early, love them, but they will say yes to everything. And so when the user starts getting focused on design elements and isn't focused on the actual need, the developer will immediately say, sure, I can do that because I can do anything with code, right? So it's important to keep that under control. All right, so yes, yep, I would agree with that, definitely. Uh-huh. Mm-hmm. Okay. Okay. Okay, so when you say proof of concept, Proof of concept to me means I'm going to build out something that's basically the real thing. It's just scaled down. Yep. Yep. That's a proof of concept. Prototyping is where I'm designing screens and it's not necessarily a real live system. Yes, but you still have to push it into production. You're not in production in those situations. Yeah. Yeah. Yep. It is very similar. Hmm. Completely different. That's just high level words. Yep. Yep. You bet. Any other comments or questions before I close out? No. Nope. Yep. This is it. Oh, thank you. I really enjoy doing this with you guys. Unfortunately, I can talk about this stuff, man. So I apologize that because I love this stuff. I apologize that we didn't get to I think we still had. This is a repeat of a lot of stuff. This short intro to UML. It's a combination of these right here. I would love to have covered use cases. I specialize in use cases, but alas, I am out of time with you. But you will be covering these 3 plus 2 more with LN. It won't take him that long. I will let him know that I was not able to get to those. And I think I will also ask the core team to, because I think that there was some replication in some of these things. If did you guys see some full, I mean, because it felt like business balanced scorecard felt like a complete replication, was it not? Did you guys already see that? I know, but like, did Peter already cover balanced scorecard with you on the first week? Or did I? I think I covered it with you, actually. I think I covered it. Yeah, but I think like business, some of them were expounded upon, but I think your balance scorecard was, I think it was the exact same. Yeah, it was the exact same. So if we remove some of those things, sorry guys, this is my first time teaching this specific session. So I was not familiar with the fact that there was some repetition, and I would probably not normally know that, because the only reason I knew this is because I covered this with you because Peter couldn't. I'll get those things cleared up. I'll let Ellen know that he's got like 5 or 6 slide decks to go through with you. All of them are pretty, I mean, sequence diagramming is only like 7 slides. Use cases is only 7 slides. There's more to it than that, but that's, I mean, that's what it is. User stories are really straightforward. That he won't have a problem getting those covered and having conversations with you. All right. Thanks, guys. I wish you guys the best. Yes. Okay, so even though I had been doing business analysis for years, I learned things that I had never leveraged when I found IIBA. Now, once I found IIBA and I got certified, I still learned a lot because I stay engaged, right? I stay engaged and things change. Things are not stagnant in our world. And my connection with IIBA gives me the direct opportunity to learn those things as they happen instead of finding out from trends in the environment. So it's definitely been valuable to me, and the opportunity to make connections. Many of the jobs I've gotten have been because of my engagement with IIBA. My opportunities for leadership, once I became certified, people actually sought me out to help them with business analysis, to teach their people, to mentor and or just come directly and lead their teams. And I've had to turn down a lot of opportunities because of IIBA. So, I mean, part of that's my experience too. But when they see that I'm certified, that raises my credibility in their eyes immediately. You know? You bet. For doing business analysis. Man, that really depends on what kind. Like, if I'm at that strategic level, I know what my company charges for my work, which is crazy. It just really depends. And I haven't, usually I get contracted through others, and my minimum charge to a placement agency is 75. If I'm placed directly, it's between 100 and 225. Yep. Oh, is it? I have no idea. I just know, because you can look at when a recruiting company places you in a contract role and they pay you between 55 and 75, that means they're making between 100 and 175, right? And I know what my organization charges for what I do, and my organization gets paid $2.25 an hour when I do what I do for them. Yep. Yep. You bet. You guys, I wish you the best. Have a great